Hello, welcome to another TensorFlow.js tutorial. Now, I'm very excited about this one. I'm generally excited about a lot of things, but in this tutorial, everything that I've done so far has just used tensors, operations to kind of create lists and matrices of numbers and multiply them and add them and optimize loss functions, that kind of stuff. Now, and I could keep going, and there's a lot that I could do with just that alone. But TensorFlow.js, I talked about this in the first video, it has the sort of core API, which has the tensors in it, the operations, and it's what I use to do a linear regression and a polynomial regression demonstration. It also has something called the Layers API. And the Layers API might look familiar to you if you've ever used something called Keras, because these are really Keras layers. Keras is a machine learning library that is a higher level that allows you to sort of create these machine learning models, and underneath the hood, a lower level code like TensorFlow will be running. So when TensorFlow.js was created, it was created with both the sort of lower level stuff and the slightly higher level stuff. And I also am working on, with a lot of collaborators here at NYU ITP, an even higher level library that's built on top of the Layers API called ML5. And I'll be getting to that eventually. In this video, I just want to talk about what the Layers API is and its core features. And so the way that I'm going to do that is by looking at a sort of basic diagram of a neural network and how you would put together that neural network with the Layers API. And the kind of neural network that I'm going to diagram is the same exact one that I did in my very long tutorial series about writing a neural network all from scratch. So the point of this is you don't have to write it all from scratch. You can just architect it with the Layers API. But if you want to like get everything you possibly could ever get, you could go back and look at some of those videos if you want. So what is so I'm going to look at a simple, well, it's not simple, but a basic feed-forward multi-layered perceptron, and it's going to have just 2 layers. So, and it often looks like 3 layers because there's also the inputs. There's the inputs, the hidden, and the outputs. That's 3 things, but technically there's only 2 layers, and you'll see why. So let's consider that we have this neural network. It's going to have inputs. Let's say that it has, I don't know, 2 inputs. Then it has a hidden layer. How many nodes are in the hidden layer? I don't know. Let's say 4. Then it has an output layer. How many outputs are there? I don't know, maybe we're doing some kind of classification task and there's 3 possibilities. It's either a cat, a dog, or a turtle. So there would be 3 outputs. You know, I started diagramming. The scenario that I'm going to do in the next video, maybe as a coding challenge, is I'm going to solve again the XOR problem. I really would like to get to some real world applicable problems, but I'm still here in the weeds of just like, I want to see how things work and use kind of trivial kind of known problems just to see if I can get the solution that I know I'm supposed to get. Okay, so if this is my diagram, if you've never seen a neural network before, again, you could go back and look at some of my other videos, but the idea is there's some data, we might call this like x0 or an x1, and that data, each of those inputs gets sent to each hidden node. There are weights here. The inputs get multiplied by the weights, added together, and then passed through an activation function, and then get sent out to each of the outputs. And so that happens at each one of these. It's very hard to draw this. I'm sure I missed a connection, which, by the way, is something called dropout. So I've done dropout correctly if I forgot to draw something, but I'll get to that in another video. So then we have the outputs, and those are, again, the weighted sum of all of the outputs of the hidden layer, the hidden nodes, comes into the outputs, pass through an activation function, and we see the result. So the idea here is maybe that I have a image with just 2 pixels in it, and two pixels come in. They get multiplied by all these weights, activated for the activation function, sent to the outputs, and then I get some values that tell me the probability of those 2 pixels were a cat, dog, or a turtle. That would be an image classification task. So how do I use the Layers API to create a neural network with this exact architecture? So the first thing that I need to do is create something called tf sequential. So tf sequential, and let's go look at that in the API docs. And I'm right here already. TF sequential is creates a sequential model, is any model where the outputs of one layer are the inputs to the next layer. That's what it says right there. And guess what? And I know, I'm sorry that I've kind of gone a little bit too high in my writing, but the outputs of one layer are the inputs to the next layer. The inputs go into the hidden, the outputs of the hidden go down. So that's exactly what I want. I should say there is also something in the Layers API called tf model, which I'll click on here. And the key difference is that tf model is more generic, so there's kind of more possibilities there. But if I really just want a simple, basic feed-forward neural network where the data flows in one direction between layers, tf sequential will work. So if I'm writing some code, I would say const model equals tf dot sequential. Ta-da! So there we go. I'm done. Well, not exactly. So that's just creating a sort of empty. So all I've done is created this kind of empty architecture. So what I need to do now, and by the way, this is what makes working with something like the Layers API really powerful. If you watched my tutorials where I did the whole neural network from scratch, it was so much easier just to have one layer, and I never kind of got to like multiple layers because I have to rewrite the code and think about the layers and how they're connected and have a loop and all this layer object. Well, guess what? The Layers API has this for you. So I can actually just say tf now, add layer. So I can actually I can create a layer. So the kind of layer that I want to create is known as dense. So what is a dense layer? A dense layer is the terminology for a fully connected layer, meaning that every node in that layer is fully connected to every node from the previous layer. And that's exactly what I have here. These are dense layers. All of the connections are there. So, and you'll see there's like other kinds of layers. There's a convolutional layer that I'll use at some point when I talk about convolutional neural networks. Other things too, but dense is where we want to get started. So let's come back and look at now the API docs for dense. And I think I opened that up here. Yes, tf layers. Sorry, it's tf.layers.dense. So I need to say const, and I'm going to call this hidden equals tf layers.dense. Const output equals tf layers.dense. So I'm missing a lot of, but this is the idea. So like I will have a model which is a sequential, and then I have a hidden layer and an output layer. And we'll talk about the inputs in a second. And then I would just say model.add layer hidden, model.add layer output. And I think I'd like to say outputs. Well, I guess it's the output layer. Whatever, let's just say output. So this is the idea. This is how, in theory, simple it is to build your own model using the Layers API. Now, what's missing here? Like I could, weirdly enough, let's just like run this code and see if we get any errors. So it cannot read property name of undefined. So, okay, so who knows what that error is? But the thing that I'm really missing here is I need to be more specific. Like I need to say when I make a layer, what is the shape of that layer? In other words, how many nodes are there? What's the shape of the inputs? How is it connected? What activation function am I using? Those types of things. So those are, if we look at the API docs, the configuration of the layer. So I need to actually configure the model itself and configure each layer. So let's go look at that and see if we can figure that out. So let's go look again at tf sequential. Actually, I think we're going to be fine right now with, there's an optional, this question mark means optional. There's an optional parameter config. What I am going to skip that right now. It could be, I could actually create it with a bunch of layers already and a name, but I'm going to skip that. What's more important here is the dense, the config object for the dense layers, which is required. So that's why I'm getting an error. This is required. So I need to specify some configuration options. And this should be listed for me here. Units, activation, use bias, kernel initializer, blah, 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 blah. And sorry for these markers here. So let's start adding something. And what that means is I need to create an object. I'm going to call it config. I could call it. And here is where I'm going to set up the configuration of this hidden layer. So what I'm going to do here is let's look at what some of these are. So units. So what I want is what's the unit? So in this case, I want to have the hidden layer has 4 units. And so I'm going to say units 4. Maybe I want to specify the activation function. So what activation function you use is a fascinating topic that you could go down many rabbit holes for different scenarios. But and I'm just going to put sigmoid in there as kind of for historical reasons. And that's also the activation function I used in my toy neural network JavaScript library. But eventually, as I start to build out examples, I'm going to be taking out that sigmoid and using other ones. So I'm going to say sigmoid. And I'm going to put config here. And maybe I'll just say config1 or config hidden. Again, I could put the object itself directly in here. There's lots of ways you could probably write this code in a much shorter way. I'm trying to write it in as long a way as possible to be most clear. So let's do that. And let's do config output. And what did I say? How many outputs do I have? 3. And I'll also use sigmoid. So I'm going to say 3. And I'm going to say, now I'm going to say config output. Okay, so things are going pretty well now. I'm going to hit refresh here. Config is not defined, sketch.js line 7. Oh, right, config hidden. Ooh, oh, interesting. Amusingly, I got this weird error message which makes no sense at all. It actually makes sense, but it's because I've got the P5 library involved here, and P5 actually has a function called model. So let me just, right now P5 is irrelevant for this discussion, so I'm just going to comment out the P5 library and then hit refresh here. Now, add layer is not a function, so I must have imagined that this is how you add a layer to the model. Let's actually go and look. And where would I find that out? Once again, if I go to, so here what I want to look at is, it's a little hard for me to find things. Oh, no, okay. I know what I want to look for, so I'm going to just search for it. I want to look for the tf sequential class. So tf.sequential, the function, creates an object that is a tf.sequential. So if I look at this, we now look that the function is just add. There's no add layer function, it's just add, which is a lot nicer, actually. So this is meant to just be add, and this is meant to just be add. Okay, so now, and this is really bothering me that it's calling this polynomial regression. So I'm going to have to change this to Layers API explanation. There we go. Okay, uncaught error. The first layer in a sequential model must get an input shape or a batch input shape argument. All right, so what did I miss? This is what I was talking about. So the inputs are technically not a layer themselves. The inputs are, in a way, part of this hidden layer. They are the inputs to that hidden layer. The inputs to the outputs layer are the outputs of the hidden layer. So one of the things, one of those properties that I have to specify is the input shape. Now, interestingly enough, it says I need an input shape or an input batch shape. And what's interesting about this is what is the difference? So here I can clearly say that the input shape is 2. There are 2 inputs. It's just, actually it's 1. Well, no. It's 2. It's an array with a number 2. It's confusing. This is what it is. It's one-dimensional. It's a one-dimensional array with 2 spots in it. But someday there might come a time where I have a data set that is just each record of that data set is 2 numbers, but I want to send in 100 of them at once. That's known as a batch. So the shape might be something like 2, 100. But this is not super relevant for right now. This is what I need to specify. So if we come back to the code, I should here, going back to sketch.js, what I need to specify here is input shape 2. And again, I made this up. Like I'm just saying, my model architecture has 2. So now I should be able to No errors. So I created that model, and I can even take a look at it here. There it is. You know, all this stuff, input layers. We can see all sorts of stuff here. Now, there's not much there, actually, because I've forgotten a really crucial step. But let me keep going. There's some more stuff to discuss. So the input shape is 2. What's the thing? How come I don't need to specify an input shape here? You would think that I might. After all, I had to say that there were 2 inputs to hidden. Why don't I have to say that there's 4 inputs to outputs? Well, the reason why I don't is because TensorFlow.js, the Layers API, can infer the input shape of the outputs layer because it has to be the number of units in that hidden layer. And by the way, it's, you know, actually naming these things like hidden and output is almost less relevant now. It's really kind of like layer 1, layer 2, that sort of thing. So, so I could put input shape here, and I would put 4. Now let's just see if I have any errors. Everything's fine. Now what if I put like 8 here? Am I going to get an error? Now, interestingly enough, I didn't get an error. That's weird. Now, why didn't I get an error? Well, maybe it should give me an error. I don't think so, though. I should get an error, though. I'm missing a crucial step here. I actually have just set up the idea of this sequential model. I have the model object, I have the hidden layer, I have the output layer, I've added them both in, but I actually haven't like plugged all the pieces into each other yet and finished it off. That has to come as a separate, it's not building up the model as you're creating it or configuring it. It's at the Layers API asks you to configure it and then call a function called compile. So I'm making list of, and this by the way was in tf.layers.dense, but another really important function here, compile, is part of a sequential object. Add was the other one, if I'm sort of keeping track of the things that I'm looking at. So add I looked at, now I also need compile. So let's go take a look at that. So if I go to the documentation, here we can see there's add, evaluate, there's a bunch of things. I'm looking for compile. Wait, maybe compile is not part of TF sequential. Oh, it is. It's just listed as part of TF model because TF sequential is based off of TF model. So this is what I'm looking for. This is me needing to compile the model. Now I need to compile it with an optimizer and a loss function. Aha! So if you watched my linear regression with TensorFlow.js videos, you might remember that I had to create something called an optimizer. And the optimizer's job was to minimize a loss function. So the same thing, the idea, you know, I just had y equals mx plus b. Now I have a more complex architecture to learn about a data set. So what I want to do with that architecture is the same, though. I want to feed it a lot of known data and have it optimize all of the weights of all of these connections to fit, and this is going to be very, fit that data. So I need to specify those things. So how do I do that? So first, I'm going to make, I'm going to call this just like config, and I'm going to say optimizer is, and so some options here, a string or a TF train optimizer. So I think what I want, I actually want to create my own optimizer, and I'm going to go do that by saying constant optimizer equals tf.train.sgd 0.1. So if you remember, this is a way, I mean, this you might not have seen before if you're watching this video for the first time, but this is exactly the same code that I had in my linear regression example. I'm creating an optimizer from tf.train. The optimizer uses stochastic gradient descent, and the learning rate is 0.1. So this will be the optimizer. So I'm going to say SGD optimizer, like that. Then what else do I need? A loss function. So the loss function can be, I could probably define my own loss function, or I can use a string. So I'm not seeing here the options for the loss function strings, but let's see. Loss function, like basically what I want to add here is like mean squared error or something as my loss function. So I don't think that's right. But let's just see now if what I would do is say model.compile config. So now, right? Let's review. Create the TF sequential object, configure some layers, add them to that model, then configure basically make an optimizer and a loss function to find those, and then compile the model with those. So I'm sure there's going to be lots of errors here, and there's things that I've done incorrectly. So unknown loss, mean squared error. So let's figure out, how do I look that up? So let's see here, mean squared. Look, I found it in an example. So losses, let's look at this. I'm just looking for the list of them, but I'm gonna come back. I'm gonna find that and then come back and show it to you. But now that I see this is just lowercase m. So somewhere in the documentation, I want to find what the options I can put here are. Let's now hit refresh. Ooh, no errors. Interesting. So this is weird. I'm surprised. I don't know if this is a bug or not, but I'm surprised that I didn't get an error for this input shape here for the output. Maybe once I started feeding it data, I'd get an error. Maybe I never would. Wait, I want to clarify something really important here, because I kind of put this in here as like a demonstration of some goofiness I was trying to figure out. But the input shape, so a couple things. Let me first mention something. Somebody in the chat just asked me, isn't it 12? Because there's 4 here and there's 3 here, and 4 times 3 equals 12. Well, the number 12, and I know I just sort of wrote that up too high, the number 12 is an important one. There are 12 connections, meaning 12 weights. But this is now, we're in the place of using the Layers API. That is specified for us. We just need to say there are 4 here, there are 3 here. And we need to say there are 2 coming into here, and there are 4 going into there. So 2 is the input shape to here, 4 is the input shape to here. Now I have this weird 8 in my code because I was kind of messing around, what happens if you put the quote unquote incorrect input shape? And so this really should, if I want my network to match what I'm drawing over there, this should be a 4, but I don't need it because it can be inferred by here. And I think what I'm going to do actually now to make this a little more readable is, I think it's, as much as I wanted to try to write this in a long-winded way, I think I'm going to take the configuration and just put it right here inside the creation of this layer, and then I'm going to take this object. I don't need to name these objects, and do this. I think this is actually easier to follow. So now you can see, I think this is easier to follow, right? So there's the model, there's the hidden layer, the output layer. I need to specify the input shape always of the first layer. And maybe what I want to do is actually say, add that hidden layer, then create the output. It doesn't really matter what order, because I'm going to compile everything. So I have let's review. Did I already do this? I might have, but I need to do it again. I need to create the sequential object. I need to make whatever layers I want, configure them, add them in, and then I need to compile it. And notice, compiling it, I need both an optimizer, which I created one, stochastic gradient descent. I could have used the adab one or any of the other ones. Again, what these are and what the formulas are, there's a lot. We could go down many different paths and rabbit holes for a lot of depth here, but I'm just kind of looking at the higher level point of view here. And then I need to compile it with a loss function. So mean squared error being one of them. And all of the loss functions are listed out here. This is where they are. So for example, so I can name it by the string, or I can actually just reference the function name directly, like this. So this should also not give me any errors. And you could see now that if I wanted to use cosine distance, I heard that that's the loss function I should be using. I could put that in here, and I could also hit refresh again, and now I'm using cosine distance. So again, what the different loss functions are, why you should use one versus the other. Hopefully I might get into these things as I start building examples and have to make those decisions, but right now I'm just looking at how you put it together. Okay, so this is going to be the layers tutorial part 1. I'm going to do a second part to this, because all I've done right now is I have created the model. And I have compiled it. The 2 things that I need to do with this is I need to send data through it. I want to put data through it and look at the outputs. What are the things I might want to do? The 2 things I might want to do is use predict. Predict is a function where I give the model inputs and I get out of predict the outputs. Presumably, I would only be doing predict after I've trained the model. So I'd want to train the model with some training data. It's finished. Then I can make predictions with new unknown data. So how do I train the model? I use a function called fit. Fit is a function that I can, basically I'm saying I want to fit, just like we had to, in the linear regression example, I had a lot of points, and I had to find the line that fits those points. I need to find all of the weights of this machine learning neural network model that fit the data. And guess what? This is what TensorFlow.js is going to do behind the scenes. It's going to do all of the stochastic gradient descent math. It's going to use its own loss function, everything underneath the hood. So all the stuff I did in that build a neural network from scratch now is now done for us by TensorFlow.js, and it has many more sophisticated options. So that's what's coming in the next video, looking at fit and predict.